Welcome to a lesson with Dr. Powell. Let's take a look in this video at a practice problem on verifying that an epsilon delta definition of a limit is satisfied by a particular limit statement. Okay, so let's take a look at this. From the previous two, we were using facts about the function that being a straight line with a constant slope. Here we will not have a constant slope. Let's see how we could work with this, though, yet still in a semi-similar fashion. All right, notice x is approaching -1 from the left side. Okay, so again, I invite you to do this on your own. Pause the video, and when you're ready, you can play it. Okay, mark, set, pause. All right, so now here's the solution. Okay, so as we're taking a look at this, we start it in a very similar way, given epsilon greater than 0, and given epsilon greater than 0, and we're going to be saying there exists a delta such that, but we know we're going to get to the point of saying let delta equal to something, and we're going to be looking for that. Look in the previous two video explanations for what's actually happening here as we move along. We're going to find some delta such that, so let delta be this, then if something, then something. So let's get that from the picture. All right, so let's draw a picture to help us. This is going to be a parabola that's facing upward, okay, with vertex negative, so -3 and -1. So it looks something like this. All right, so, and vertex is -3, -1, and it looks like we're approaching -1 from the left side. So this is x equals -3, so x equals -1 will be up here, and we're approaching it from, okay, so x equals -1, want to get out 7 here. You can just throw in and see. I mean, -1 plus 3 would be 2. 2 squared is 4 times 2 is 8 minus 1 is 7. Yes. Okay, so this is going to be what it is, but let's verify the statement is holding, and notice this is just on the left side. So we know we're going to be going up and down, up epsilon, down epsilon, and then we need to find a delta such that if we just go out, but just on the left side only, go out on the left side, then we're going to be within the function is actually between these two lines, epsilon above the middle guy and epsilon below the middle guy. So it's between this line and this line. So to do that, you notice in the picture the point of exit entry on the left side is sufficient. If delta goes that way, that's good enough. So we can see there is a delta from the picture immediately, but let's figure out what that delta should actually be computationally. All right, so to do that, let's think, all right, it's going to be intersecting right here, intersection between which two lines? So this line down below, which is y equals 7 minus epsilon, right? And the curve itself, all right, that's the curve itself. I'll just say, I call it f of x. So, so there's, I guess there's, but when f of x comes right here, we're going to get an x value, right? And what is that x value right here? This is, well, it's delta before -1, so maybe we can just kind of do this, make this a little bit more clear here. Okay, so the x value, so let's see, and we're going, so the x value right here at this point is what we're heading to. That's x equals -1. So this is at x equals -1. This guy right here is delta over from -1. So x is equal to -1 minus delta, moving that way, moving to the left. Okay, so this point right here, we have some information about it. We know its y value, we know its x value, and we also know the function that we're plugging into because it's on the curve. So we could even think, okay, so this y value, we know what it is, but we also know it can come from just plugging this guy into the function itself. So in particular, we know that f of -1 minus delta is equal to 7 minus epsilon. This is enough to help us find a relationship between delta and epsilon. The function, all right, is this. So we can kind of think, okay, so 2, we're plugging this in for x, so -1 minus delta plus 3, quantity squared minus 1. All right, so that's the function. So the function is really this part right here. This is the function. That's f of x. Okay, so we just plugged in -1 minus delta into the function. So this part represents this side. This side is this part, and that's going to be equal to 7 minus epsilon. Now I have an equation that relates delta to epsilon. Now I have to be careful in this situation when we take square roots to notice what if we're going to take a plus or minus, but we'll talk about that as we go. So here let's isolate the square root. Let's see, we can add 1 to both sides. So we get 8 minus epsilon, and if you want we can divide both sides by 2, and that's going to be equal to, then we can simplify in here, -1 and 3 is 2. 2 minus delta, quantity squared. We're trying to figure out what the delta is for this given epsilon. Now notice that 2 minus delta itself, let's see, yeah, so 2 minus delta, delta is a small number, positive number, so 2 minus delta will be a positive number, right? So, so knowing that 2 minus delta itself is a positive number, when we square root, we want to get that 2 minus delta as being positive. So we're going to be taking, we want a positive square root, not a negative square root, in order to get around what 2 minus delta is here in the situation, because delta is a small number. So square rooting, we're going to get 2 minus delta is equal to, we're only taking the positive square root 8 minus epsilon over 2. All right, so what is delta? Well, a little swapperoo, add delta over here, subtract that. So you're going to get 2 minus the square root of 8 minus epsilon over 2 equals delta. That would be an acceptable delta value. So if we take that and we put it up here, so let delta be equal to 2 minus square root 8 minus epsilon over 2. Okay, then if what? Well, if x is right here in this little spot between this point and this point, so in here somewhere, how do I represent that to the left of -1? So basically we can have that -1, so -1 minus x is to the left, so -1 minus x will be a positive distance. We want that positive distance to be, so we can relate it to the positive distance of delta. Yeah, so -1's on the right of x is on the left of -1, so that's a distance, and we don't, and we're going to assume that perhaps we can have maybe we have a hole, but we know we don't in this particular case, but we always exclude the case when x will be actually equal to -1 itself. So then we just have 0. So that's the condition for being in there. So if we're to the left of -1, just away by a distance of delta, or within that, strictly less than, notice. So if 0 less than -1 minus x is less than delta, then what do we know? We know that f of x minus 7 is going to be less than epsilon. And this proof will work here in this, this statement holds. How do we know that this choice of delta works? By the picture and by our are working out here of figuring out what delta is in terms of epsilon. So that this is sufficient for intuition's sake in figuring out what that delta should be for that. And that concludes that practice problem. Thanks for watching.